Hello and welcome to Unit 1, Week 3 Density Lab. So let me start off with having you get your science learning journals and opening up to a fresh page, and I'm going to give you a little lesson about density. I'm going to provide for you some key concepts that you need to know before you begin this lab. So go ahead and write these down in your science learning journal. Feel free to pause the video in order to get these written down. So the first key concept is a submerged object displaces a volume of liquid equal to the volume of the object. And number 2, 1 milliliter of water has a volume of 1 cubic centimeter. Number 3, different atoms have different sizes and different masses. And the mass of atoms, their size, and how the atoms are arranged determine the density of a substance. Number 5, density equals the mass of the object divided by its volume, or in other words, D equals m over V. And number 6, objects with the same mass but different volumes have different densities. So now we're ready to begin our experiment, but what I'd like to do is teach you how to keep your lab notes in your journal instead of writing them on a worksheet. So I'm actually going to have you transfer to your science learning journal and go ahead and give it a title, Density Lab. And a good scientist always has a problem to solve. So here's our problem for this experiment. Using the displacement method, can you find the density of 5 unknown objects and identify them? So go ahead and copy that down. In today's lab, we are using the displacement method to find the density of 5 unknown objects and then identify those 5 objects. So at this point in your directions, it says to watch an animation. So rather than having you go online and look at that, I'm going to go ahead and show you the demonstration here. What we're going to do is use the water displacement method to find the volume and the density of this object, this marble here. So we are going to use the water displacement method. So I need a scale, I need a graduated cylinder with some liquid, and I need my object. Now the first thing I want to teach you is how to read a graduated cylinder. So what you need to do is put your eyeball right up to where the line is, and you will notice that there's almost two layers of water, a top layer and a curve, a bottom layer. You always want to read from the bottom of the water, not the top of the water. So if I read from the bottom of the water here, it'll show me it's at 70 milliliters. So that bottom curve is called a meniscus. So a meniscus is the bottom of the curve. So this is my graduated cylinder. I look at the bottom where the arrow is pointing, and it would mean that there are 68 milliliters of liquid in my graduated cylinder. Not 70, but 68. I read from the bottom of the curve. So now that I'm reading from the bottom of the curve, I see that it is 70 milliliters. So now I need to figure out the mass of my marble here. So I'm going to put my little dish here. And my dish weighs 8 grams, but I need to zero it out. There we go. So now I'm going to put my marble in there. And it says 5 grams. So now I'm going to record my density. Sorry about that. So density is mass over volume. D equals m over V. So we're going to calculate the density of that marble. So I know my mass is 5 grams. Now I need to find the volume. So what I'm going to do is use the water displacement method to find the volume of this marble. So I'm going to pick up my marble here and I'm going to drop it in. So I remember it was at 70. So now what I do is I bring my eyeball really close in and I look at the bottom of the meniscus. And what I see is that it's about 72 milliliters. So 72 milliliters is not my volume. It's the total volume. What I need to do is subtract. So my ending volume was 72 and my beginning volume was 70, which means the water displaced was 2 milliliters. Now I learned from my notes earlier that 1 milliliter of water is the same as 1 cubic centimeter for volume. So that would mean 2 milliliters is also the same as 2 centimeter cube. So now I can plug in my information. Density is mass over volume. So the volume of the marble is the water displaced, which would be 2 centimeters cubed. So if I were to divide that out, 5 divided by 2, I would come to D equals 2.5 grams per centimeter cube. So my density of the marble is 2.5 grams per centimeter cube. So again, I used a scale to find the mass. I used a graduated cylinder, and I displaced the water. I measured the water before, the water after, subtracted, and this tells me the volume of my marble, which I can then plug into my formula. D equals mass over volume. 5 divided by 2 is 2.5 grams per centimeter cubed. So let's go ahead and begin our experiment. So now that we have our problem, the next step would be background, but that's what I provided earlier with our little lesson on density. So now we're ready for our hypothesis. Now what I did, just to make it easy, is I just took this and cut it out and taped it right into my journal. So here is your hypothesis. Which do you think is the most dense, medium dense, and least dense of these 3 objects? So let's compare the tallest, the longest one, the medium, and the smallest. Now these all weigh the same. If they all weigh the same, what do you predict will be their densities? So go ahead and right now on the line, do you think this one would be the most dense, the least dense, or the middle dense? Write it down, write it down, write it down. So take a moment to do that. Okay, so now that we've made a hypothesis, let's go back to our handout. And here they ask you to watch an animation, so please take time to do that before you start the rest of this video. Take time to answer these questions using the information I gave you and the information from the video. And then we're ready to begin our experiment. Now what I did was I took these data tables and I transferred them into my Science Learning Journal, and I will record my data here. Now these are a set of equal mass rods, and the masses should be all 15. So checking out if that's true, let me zero out. So here's one of them. So we have 15 here. Good. So so far so good. So just to be safe, you should probably weigh each one just to make sure that they are all 15. And then we need to find the initial water level and then the final level and the volume of the rods. So we're going to drop each one in water using the displacement method. Okay, so now we're ready to begin. I did go ahead and fill in some of my data table. I set my graduated cylinders all at 70. And then my rods are actually numbered, not lettered, so I just kind of added that to the data table. You don't really have to worry about it, but A is 1, B is 2, and so forth. So they go from tallest to shortest. And so we're going to use the displacement method to calculate their volume, because I don't know what their volume is. So I'm going to use this graduated cylinder. Again, I apologize for it being difficult to see, but it's set right now at 70. So I'm going to drop my number 1 or A in. Okay, and now if you notice it floats, and so I need to poke it down a little bit. So I'm putting in a stirring stick. I'm going to push it just down to right below. And looking at the meniscus, I would say it is about 85 milliliters. So now I'm going to write down in my journal. First thing I wrote down is F for floats. I want to kind of keep track of what sinks, what floats. So object 1, even though it's really long, floated. Its final water level was 85. So then the volume of this, you subtract, is 15 centimeters cubed or milliliters. And then I know it's 15. So I can calculate the density right now, but I'm going to go ahead and continue working, and then you can fill in these densities. So let's go ahead and measure object 2. All right, so now I'm going to look at object B, or 2. And again, I have a graduated cylinder set at 70. So I'm going to drop it in, and it sinks. So I'm going to take note of that on my journal. And then I'm going to take a look at the meniscus here, and it looks to be about 85 84. So, looking again, yes, 84. All right, so I want to make note that it actually sinks, and then record 84, and then I subtract, and that is 14. And the mass is 15. So I'm going to go ahead and continue working. Now I'm going to do object number C, or 3. All right, here's my next graduated cylinder. I'm going to look at object 3, or C. It's the middle one. We're going to drop it in. Definitely sinks. So now I'm going to turn it here and look at the meniscus. And it looks to be about 81. So again, let's go back to our sheet. So this one sinks, number C, or 3 sinks, and then it was 81. So subtracting 81 from 70, and I have 11 for its volume. Next object. All right, here we go with object D, or number 4. It's the little silver one. I'm going to plop it in. Sinks. All right, so let's take a look at the meniscus here. And it's about 75. So, going back to our data table, write your observation that it sinks. And then the final water was 75. And the volume of that rod then was 5. Last one. We're ready for our last measurement. I have now the little gold one. It's a number 5, or E. It's the shortest one, so let's drop it in. Sinks. So go ahead and record that. And now let's take a look at the meniscus. And I would say the bottom of the line is about at 72. So let's go ahead and make our record. Sorry about that. So it sunk 72. And that would be only 2. So as the objects got smaller, what do you notice about the volume? Got smaller as well. So let's now calculate density. Now again, density is mass divided by volume. The volume's been converted into centimeters cubed. So I'll work the first one with you, and then I'll leave you on your own for this. So in terms of our first volume, it's 15, and the mass is 15. So I don't really need a calculator for that. 15 divided by 15 is 1 grams per centimeter cube. So I know the volume of mystery rod number 1, or A, is 1 gram per centimeter cube. So go ahead and now divide mass divided by volume, mass divided by volume for each one of these. Let me give you a quick tip. As you're working on these, you'll notice that you're going to get some pretty long numbers. So I definitely recommend you rounding to the 10th. So instead of 1.0714285 on your paper, go ahead and round it. So it would be 1.1. That would be fine. So go ahead and round to the 10th for each of the objects. So now that you have written all of your densities, we're going to then see if we can guess which object was which. So right here in our conclusion, we have the answers. We have the approximate densities of each of these objects. One of the objects is brass, aluminum, PVC, nylon, and polyethylene. So your job is to now look at these densities and see if they are similar to the densities you found here. Can you tell which object is which? So remember, this is not exact science. There were some flaws, of course, in how we were reading the volume and so forth. So it's not going to necessarily be the exact number, but it should be pretty close. So let's see if you can do it. What letter is which object looking at these densities? So go ahead and do that. And then in number 5, it asks you to go back and look at your prediction. Were you right about your predictions to the tallest, the medium, and the shortest? Which one was the most dense, the least dense, and medium dense? So go back and look at your hypothesis and see if you were right or wrong, and answer these questions as part of your conclusion. Now, to find the answers of these, you can go ahead back on the wiki, and there is an answer key. So you can check how you did and see if you guessed the mystery rods correctly. So thanks for tuning in for our science lab today. Have a great science day.